Okay, so lesson 2 is on angles associated with parallel lines. There's a lot of definitions and basically theorems that you have to know in this lesson. So moving on, so in the beginning, the first thing we need to do is talk about what a transversal is. And so a transversal is a line that crosses two parallel lines. A line that crosses two parallel lines. So remember, parallel lines are indicated with almost like a little arrow. So these two lines are parallel because of those arrows. They tell us that. So this line, this is the transversal because it crosses two parallel lines. Now, there's going to be some really cool properties that occur that we're going to learn about when a transversal crosses two parallel lines. So make sure you know what a transversal is. So let's first talk about corresponding angles. So the dashed lines were drawn with a ruler and a set square. Okay? And so the dashed lines are parallel to each other. So we have a ruler. Their marked angles are all copies of this of the angle of the set square. So measure out all the angles. So we're going to grab a protractor. Bring it down here. I'm going to rotate it. And there we go. So we want to measure each one of these angles. I'll start with this first one. Now this line is a little, make sure, center. Okay, so it should be, as long as we're lined up properly here, it should be about 45 degrees. Okay, so we have here, it should be, I think yours will be more accurate than my giant version, a 45-degree angle. So the first one, if we move up, and you could probably induce this as a pattern, right? Or deduct that it's going to be 45 as well. So we have another 45. We keep moving this guy up. Stop moving. Up here, again, 45-degree angle, and again, 45-degree angle. So they're all 45 degrees. And 45. So are they all equal? And the answer is yes. And so corresponding angles almost form like, so here all of these lines are made so that they were parallel, and this ruler line is like our transversal. So any pair of lines making an F shape with a transversal, we call those corresponding angles. So this angle A and angle A are corresponding angles, and corresponding angles are going to be equal. So it says on the diagram we're going to draw as many F shapes as we can. So it helps if you have like a highlighter or something a different color. So I'll start, the most obvious F shape is probably this guy. Now the F shapes could be, it doesn't have to be exactly an F. It could be a backwards F, right? So we wanted to have two parallel lines and the transversal cutting them. Okay, we could even go upside down. So transversal, go left or right. It really doesn't matter. So let's use these two. So transversal, parallel line. So that's that kind of F shape. And so here's an example. This would be corresponding to this one here, those two. Our corresponding angles would be here, right? So it's the two parallel lines and the transversal, and these are corresponding. And then D and, oops, sorry. We want it wrapped with the transversal and the parallel line. So those are all corresponding. Okay, and there's actually another set which was already drawn above. So I should almost have done, instead of doing this one here, B, because it's already above. What's another way we could have drawn it? Grab my highlighter. Right. So we have we also have this one here. I guess we didn't talk about that one. So if we compare all of the above, so we actually have B and B. These are the four different corresponding angles. So there's four ways we can do that. And so it can be upside down, it could be backwards, RF, but that is what these angles here are, all corresponding angles. And so you might want to put those on your study sheet. Okay, so use corresponding angles and straight angles to calculate the each marked by a letter, each angle marked by a letter. So let's first find the first corresponding. Do you see the first corresponding? So here is my transversal and then parallel line. Oops. Undo. Transversal, parallel line, parallel line. So angle A is equal to 120 because it's corresponding with the 120. Corresponding. It's good to put the reason in brackets because you're going to see we're going to have to do proofs later on. So you have to know the names of these angles. Not just, oh, I know it's 120 because we've done that before, but it's called corresponding. Now angle B we can get because, why? Why can we get angle B? What do we have here? A straight line. If we know A is 120, then B is going to be 180 minus 120. And why is that? So in brackets we're going to write because it's a straight line, so straight angle. So 60 degrees for angle B. Okay, let's look at the next guy. So our transversal, the parallel lines don't have to extend. If it'll make it easier, you can extend your parallel lines. But right here's a parallel line, here's a parallel line. It doesn't necessarily have to keep going, like so. And so we have two sets of transversals, two lines that cross. Just move this up out of the way a bit. There you go. Transversal has to cross two parallel lines. So we have two of them here. So do you see any of the F shapes? Any F shapes? How about this one? Right? And so our corresponding would be there and there. So you can start with C. C is equal to 124 degrees. And why? Because of corresponding angles. There's another F. Remember, F's could be backwards. There's one here. Oh, that's not going to, oh yeah, okay. And here. So 132 is equal to E. E is 132. Again, why? Because of corresponding. And now we need to get D and F. So let's start with D. How do we get angle D? Again, we have a straight line. So if we know C is 124, D is going to equal to 180 minus 124. And what does that give us? That gives us 76 degrees. Nope. 56 degrees. Sorry. 56 degrees. And why is that? The reason is because we just use straight angle properties. So 56. Now there's two ways we can get angle F. You can either use straight line, or we know a four-sided shape adds to 360. We're going to use straight line because that's what it asked us to do in the question. So we have another straight line here. So F would be 180 minus 132. And what does that give us? That gives us 58 degrees. And why? Because we use straight angle properties. So we want to put our reason behind it. So 58. Okay. So on a test, you could be asked not just to solve it, but explain your reasoning. So what property did you use to say that they're equal? All right, we're going to find out another property with a transversal and two parallel lines. So another shape we can make if we have two parallel lines and a transversal cutting it is a Z shape, like this. Okay, so the transversal can make a Z instead of an F. So is there any relation there? So we're going to measure angle A up above. Well, here's a proof. So here's that Z. So we're going to extend, what happened is they extend both straight lines. And these are both 50 here. Why? Because of opposite angles, right? Remember, that's opposite angle property. So having on your study sheet just the diagram is not enough. You need to know, okay, why are they equal? It's called, what is it called? It's called opposite. And then we can deduce, well, angle 50 in here, we just already learned that those are equal. Why? Because of corresponding angles. And so therefore, we have 50 and 50 here are going to be equal. And they're called interior alternate angles. Interior alternate. They're on the insides, and they're alternating. One's on one side, one's on the outside. So we're going to measure each of the following. So grab, again, your protractor. Mine likes to go up high. Okay, we're going to measure each of these angles. So I'll start with this angle here, and I notice it's a 60 degree. So you can see it goes to 60 degrees. 60 degrees. And we need to measure the other side. So I'm going to rotate this upside down. And actually, I already have my thing marked. It's also 60 degrees. 60 degrees. Okay, that's cool. Surprise, surprise. Maybe not. Let's measure the next guy. So rotate him right there. And we'll move this. This is 40 degrees. 40 degrees. And then let's rotate it to measure the other side. We'll move this over here. And again, notice it's also 40 degrees. So they're both 40. So it looks almost like it's a sideways Z. It's like an N almost. And then here, this is a larger one. So let's rotate this guy and measure his angle. We're actually going to start from over here this time. On the other side. I kind of hate when they're these half angles. 70, no, not 75, because there's zeros over on this side here. So if we go all the way up, that's 105 degrees. Let's rotate our guy and measure this angle. And again, 105 degrees. Okay, so that shouldn't be a surprise. And what we call these angles, when you have two parallel lines and a transversal, and they're on opposite sides of each other, or alternate sides of each other, they're called interior alternate. They're on the inside, other than, because we're not using the outside angle, we're using the inside. So interior alternate angles. And so they almost make like a Z shape. So, and they are always equal. Interior alternate angles are equal. So another property that should go on your study sheet here, right? Or you need to know this. And there's really two sets of interior alternate angles. In this diagram over here, there's A and A, but there's also, we call this B and B, are also interior. So our Z can be backwards as well, right? So there's two sets of interior alternate angles. So it says use interior alternate angles and straight angles to calculate the following. So we want that Z property. So we start with a parallel line. So I'm just grab my highlighter here. So here's parallel, and we want to go down the transversal and then along the parallel again. And so B is interior alternate with 69. So B equals 69 degrees. What's the reason? Put it in brackets. Interior alternate angles. Sometimes they're just called alternate angles. I have a habit, going back up here, alternate interior. I have a habit to write interior alternate. It's really the same thing. Alternate interior. It's kind of nice having the alternate first because it's, I don't know, it's easier to remember. Oh yeah, they're alternate of each other. Alternate interior angles is the reason. So now we know B is 69 degrees. Do we see another Z? It might be backwards or mirrored. It's purple. So we want to, here's our parallel line, transversal, parallel line. So where are my interior alternate? Or alternate interior, A and 47. So A equals 47 degrees. Why? Because of alternate interior angles, or alternate angles. That's the name of it. Get in the habit of not just filling them in, but also writing the reasons, because when I ask you to do a proof, you got to know these names. So if you get in the habit of writing in the reason, you're going to be good for the proofs. Okay, so now we know, how do we get C? There's a couple ways. It wants us to use straight angles. It doesn't want us to use 180 in a triangle, but that's okay. A straight line is also 180. And we know A is 47. We know B is 69. So C is going to be 180 minus A and B, 69 and minus 47. Because a straight line here adds to 180. So grabbing your calculator, 180 minus 69 minus 47, and that gives us 64 degrees. 64 degrees. 64. There you go. Okay. So, and why is that? Reason again, straight angle. A straight angle. Let's try this guy. Do you see the two parallel lines? Like, you might want to grab your a highlighter always and just kind of like, okay, highlight parallel line, because then you can see your transversal. And where's our transversal? It's this guy right here is our transversal. So who are interior alternate? Interior alternate angles. Okay, 42 is equal to D. Those are our interior alternate, or alternate interior. Bad habit. Alternate interior angles. If you want to just call them alternate angles, that's okay too. Okay, so we have 42 here. Now there's no other way we can do, well, there is another transversal, right? There's this transversal. I'll show you. Right here. So there, purple is our parallel lines. So we know, like, for example, E and F are going to be equal to each other. Why are they equal to each other? Remember, what do we call those? These ones here that make an F symbol with our parallel lines, those are called corresponding angles. Okay, now they also mark, there's obviously a reason why there's two dashed lines. And what do we call triangles with two dashed lines? Those are isosceles. And this is expected that you already know this. Isosceles triangles have two equal sides, but they also have two equal angles. The angles opposite of the equal sides are equal. Okay? And that's something that's you're expected to know. You're expected to know this. And so if you don't, you better learn it now and write that on your study sheet. So we know if we knew this, if this is E, this is also E. And so E plus 42 plus F will equal 180 degrees. Right? And so let's find, we also know then if E and F are equal to each other, then this angle, because of the corresponding, right? Corresponding, then we can assume that for a straight angle, it's going to be 180 degrees will equal to our 42 plus our E plus our F, which is also E. So if we're trying to use straight line properties, 42 plus 2E. Now you could also use 180, right? Our isosceles triangle will add to 180, which is derived from a straight line property. So if I subtract 42, take away 42, what will that give us? 138. And that's going to equal to 2E, and so all we have to do is divide it by 2. And so our angle for E is 69. 69 degrees. And so, and really, why, so that's E, that using a straight line property. And so F, Y, and E and F the same. We've already talked about this one just right away. So F equals 69. Why? Because of corresponding angles. Corresponding. And so that's the F property. The F property. Okay, it's called corresponding. Okay, so turning over. If your lines are not parallel, then those angles won't be equal to each other, right? So then, for example, A and E will not be equal to each other if the lines aren't parallel. If they are equal to each other, then we can deduce, oh, obviously because those angles are equal, the lines have to be parallel. We're going to use that property in proofs. Okay, so if they're not equal to each other, the lines are not parallel. If it's not, we don't have corresponding or don't have alternate interior angles, then the lines are not parallel. So co-interior angles is another property that you need to know. And so let's grab a protractor and just measure and see what happens. Okay, so here we go. Now, they're assuming that what we're dealing with here is two parallel lines in all of these cases, I should state. Okay, and then we have, of course, our transversal. So if we measure angle X, I get 75 degrees. It's kind of moved, but 75 degrees right there. So X is 75. And then if we rotate this, let's make that smaller. Smaller. Oh, this thing. Sorry. And rotate it other way and measure angle O. So we're starting from 0 here, going all the way, and I get 105 degrees. 105 degrees. 105. So what's so special about 75 and 105? Well, let's look at this next example. So again, we're measuring. And this time so I'm doing the top angle, and again, 75. We rotate it, measure the bottom, and 105 again. Okay, so 75, 105. So what's so special about each one of these? Okay, let's do one more. I don't think that second one was supposed to be identical, but it was. So we have a 60-degree angle, and then if we rotate, measure O, it is 120, right? 120. So we're starting, oh, sorry, I measured the bottom one is 60 when it was 120. The top one is 60, and the bottom was 120. And so co-interior angles, what can we say about them? Are they equal? No, they're not equal, but there is a relationship, right? Co-interior angles add to 180. They sum to 180. So we can a name for that, another term you need to know, is that you could say that they are supplementary. So supplementary means that it's when we have two angles that add to 180. Two angles that add to 180, then they are supplementary. So co-interior angles are supplementary, or add to 180 is another term. So we can use that property in parallelograms. If we have two parallelograms, here's, for example, one parallel line, another parallel line in our transversal. So this angle here would be co-interior. Co-interior. And so how could we get that angle? Well, 180 minus 48 degrees, which is 132 degrees, because they are co-interior. Co-interior angles. Co-interior. But then we could do the same property again. We'll just rotate. Here's a parallel line. Here's a parallel line. So 132 and this guy are going to be co-interior angles. So how do we get the other one? Well, 180 minus 132, which gives us 48. Again, co-interior angles. And then same property again to get the other one. And so in a parallelogram, that's a really cool property where the opposite angles are equal, because there are going to be 4 sets of co-interior angles. All right, so summary of this lesson, very important. Corresponding angles are equal. So remember, this is like your F shape. Your F shape. Alternate angles are equal. So this is when we have our two parallel lines. And a transversal, this is like our Z shape, our Z. And co-interior angles are supplementary. So X plus O equals 180. If a transversal intersects two lines such that the corresponding angles are equal, alternate angles are equal, or co-interior angles are supplementary, then the two lines are parallel. So it's just saying the opposite. So if the above three are true, then we have parallel lines. And that's it for this lesson.